Ikan, should we start?
Yeah. Good evening, all, and good evening, good afternoon, based on where you are. Welcome to this demo session of EV performance planning for e-commerce and trade delivery training program. This is a professional certification program that is organized and conducted by SAP Manifold evacademy, and our certification partners are Automotive Skills Development Council. So once again, welcome to this demo session. We will go through around 15 to 20 minutes of content, which will give you a teaser and a flavor of what can be expected from the training program. And after that, we will open it up for Q&A. I have with me my partner Rahul and also Somshekar. So three of us are the primary trainers for this training program.
Good evening, everyone.
Good evening.
So why we should talk about the electrification of the freight or the light commercial vehicle fleets. So as you can see, these are the projections for how each of the vehicle segment will grow in terms of EV penetration. And one of the fastest growing segment is the light commercial vehicle. Right? As you can see here, it is similar to the passenger vehicle growth. It has a similar growth as the passenger vehicle segment, and it is the fastest growing segment projected among all the other vehicle segments. And because of that, this is a global statistics, but this is also reflected in India, as we keep seeing news like the e-commerce giants are aggressively electrifying their delivery fleets, and the OEMs are gearing up and getting excited in this segment. So there will be lot many offerings coming out in this segment as compared to some of the other segments. So the challenges of having e-fleets, some of you might be working as the fleet owners or fleet operators, and you would be familiar with some of these problems. So some of the challenges are in terms of vehicle, getting the right vehicle for the particular application, getting adequate supply of those vehicles wherever you are setting up, whichever city or region you are setting up those operations, and then the support. We always in our work come across this as one of the major challenge: the right vehicle, the right supply of the vehicle, and the right support. These three go a long way in setting the operators at ease and getting the vehicle operational and keeping it operational for most times. The other challenges include, which are subsets of having one of these three. So, for example, selection of the battery, sizing of the battery, taking considerations while operations like the aging, degradation, if there is any for any particular reason on a particular day and route, there is abnormal energy consumption, abnormally high energy consumption, which leads to range anxiety. And then it could also vary based on the operating conditions. The range could also vary based on operating conditions, based on how the vehicle is driven. And because of that, we often see there is a large deviation of this range from the specified or claimed range in any particular application. And that those, if they are not looked into in advance, they will not only cause uh, your expectations not being met, but also in your operations they will have problems like not meeting the SLAs, not meeting the utilization, or too many redundancies required in the system, and so on. So all of this eventually will lead to your bottom line getting affected. Your cost of ownership or running the fleet is going to be high. We all know the capital expenditure of electric vehicles is typically higher, but the operating expenses is where we see a distinct advantage in electric vehicles. But if they are not planned and deployed in a systematic manner, you quickly start eroding that advantage in OPEX, and the total cost of ownership starts turning against you. So it is extremely important to first get the right vehicles, ensure the right support, and also to set up the fleet operations around the typical characteristics of the electric vehicles, so that you work with their strengths and you do not you minimize the risk because of whatever challenges are there currently with the electric vehicle operations. Another pie here, which is worth talking about, is also the charging infrastructure. Because the vehicle alone is not sufficient, you also have to worry about how the batteries would be recharged, and optimally so. Also, what is the running, how many times you require the charging, what spec chargers would be required, where that charging would happen, and so on. So this is also a major consideration which comes with electric vehicle, and it also has to be taken into account in the scheduling and the planning, both in terms of the charging time as well as the expenses of having a charger and the charging infrastructure. The typical e-commerce fleet, they would have some of this is a very specific. These are very specific terminologies used in operations of such fleets. So there is first mile, which is basically the pickup from the seller, and there is mid mile, which is basically between the hub, the warehouses, and the dispatch. And then the last mile constitutes to the deliveries that we all get as customers from orders that we have put on the e-commerce sites. So different kinds of vehicles are used in these sections, even in terms of IC engine vehicles as well as whatever electrification is happening currently. So we have light commercial vehicles around 2 tons, 2 to 3 ton GVW vehicles doing the first mile and the mid mile, and the two-wheelers, and to some extent now the three-wheelers doing the last mile work. Even in the first mile, sometimes the three-wheelers can also be employed. And then as you would see, the products that we have currently in terms of electric vehicles, a lot of them are coming in the three-wheeler L5 segment, which could potentially also make up for the light trucks that we see otherwise in IC engine counterparts. The first and last mile use case. So this is an illustration. We will study many other use cases of different operations, like grocery delivery or vegetable vendors going around. So I actually see them every day now, having those modified small e-three-wheelers, e-rickshaws. They bring in the vegetables door to door, and many other such applications. So this is an illustration of the e-commerce first and last mile use case. So typically a duty cycle comprises of the velocity, vehicle velocity versus time, and it captures the route specifics like the traffic, the driving, the route itself is characterized by this, depending on even not only the speeds but also the gradients, road gradients, and so on. So this is a typical use case where you have a certain commute from the hub to the particular delivery area where the delivery person is supposed to do a number of deliveries. And then once he reaches the first delivery, he or she reaches the first delivery point, from there on, there will be frequent stops, long stops, 5 to 10 minutes long, for the delivery to happen, and then up to the next. And it could be a commute of around, say, 500 meters to a kilometer between those deliveries. So typically, there are grids and regions or pin codes that are catered to by 1, 2, 3 of these delivery people. So the typical vehicles used, as I discussed, are the 2, 3 wheelers and vans as well as mini trucks. So three-wheelers are more dominant now in the electric vehicle fleets, whereas in the IC engine fleets, we have vans and mini trucks mostly taking up those tasks. Same is true with pickup. It could be inverted. Basically, going out of the station, you would be actually not loaded, and then you would pick up from each of the seller and come back loaded, as against the delivery where you start completely loaded and you gradually deplete your load while coming back to the hub. Typical trip lengths, depending upon the size of the city and also the coverage of a particular pin code or a grid area, is anywhere around 30 to 60 kilometers. There could be some cases where it is longer depending upon where the hub is situated, and how much area is to be covered. But these are the typical distance ranges. And the duration of these trips, primarily because it's a delivery trip and there are frequent stops, it would be around 3 to 5 hours. So typically, there might be delivery schedules in the morning and in the afternoon or late evening. So using this example, let us also understand how one can approach the deployment. So first of all, the makeup of the fleet, the deployment of the fleet, the deployment of chargers, and then how to schedule the operations in an optimum manner. And then all of this will tie up into the financial modeling. And this is, as you can see, this is not end. You do these financial models, validate against the SLAs, validate against your operating margins, and it is an iterative loop. As you can see, you have to go around this loop multiple times, and you can imagine if you start doing this, all of this on a physical pilot, how many loops you would have to do with those pilots, and how time consuming it would be, how much trial and error it would involve, and how much cost it would take. Rather than that, what we propose is doing some of these loops, at least some of these initial studies, using some virtual models, which would be not very complicated models in some exotic tool, but very simple Excel-based models to understand these steps, how to do these steps, actually doing these steps, and using the case study, arriving at the first conclusion, and then doing some loops of this based on certain disruptions, certain other considerations, maybe cost optimization, maybe the trying to meet the SLAs despite some of the disruptions that we can foresee. So all of these activities is what we will do in this course, hands-on. So it's not just about knowing that these are the things which affect, but also actually studying them, studying the sensitivities of some of the things like loading, driver behavior, ambient conditions, and then bringing those things into the entire planning. So each route can be mapped, each vehicle can be mapped to its performance and predicted for different scenarios. And using those scenarios and the probability of each of those scenarios, or frequency of each of those scenarios, you can schedule the operations, taking into account as many things as you can, building the robustness into the plans and the schedules, and then rework the financials of it. And before you make any decisions of buying a particular vehicle or going along with certain charging services or swapping services, you can actually do these loops, understand what is the optimal solution, and then go forward with those decisions and proof of concept or pilot studies. You
Vikrant,
want to add?
I want to add few things. The participants may be coming from different background, so I think this is a very, very good framework and very powerful one to see like where do you stand in terms of your EV fleet, freight fleet operations, and accordingly you the application of this framework may get a tweak little bit, right? For example, if you are a startup where you are kind of thinking of moving your fleet or getting into a new business of EV fleet, freight fleets, then this is a very powerful framework where you start from very basics, like what application you want to solve in two-wheelers, using two-wheelers, three-wheelers, what Vikrant just explained in terms of last mile, first mile, mid mile. So you may have a different scope of work that you have selected, and according to that application, you look into like what vehicle that you will be targeting for your fleet, and then you have to make a selection of that vehicle. Yeah, so this framework is allowing you to select those first top choice that you think you would want to do, and the city where you want to apply that thing, so that where you route selection and duty cycle profiling comes into picture. You first develop their energy signatures, like what those different trips using this particular vehicle in your city, doing this e-commerce or freight application will require. So those energy signatures you develop here. Yeah, and that energy signature allows you with a more realistic specifications that you will need in your vehicle. As Vikrant stated in his earlier slides, that one of the key problem, because it is still an building industry, right? Or the entire industry started from passenger EVs, and many of them are actually in phase of using some existing platforms, either of passenger EVs or of the previous passenger lead acid battery models, or even the earlier IC models, right? So many of the OEMs are kind of using these models to bring this right freight EV product to you in a time fast manner. But in doing that, sometimes your specific application need may not be getting catered, and that's what start becoming the pain point when you kind of get those vehicles, start running the fleet, and then you discover a lot of issues. So that battery sizing and charging strategy then gets developed with respect to that select option that you have chosen, and then you complete the operations that okay, then you do the TCO. Yeah, like many of time we start with a top line TCO. We start with a top line TCO that is available in the market, and we try to base some heuristics from it, right? What we have seen that those heuristics may lead you wrong. Either you are taking them too favorable for your applications, which many of the people who are running the fleets, they are finding it when it gets into things, or it could be the other way around, that you are thinking too negatively about the issues, but it would actually be working in your favor, right? So rather than heuristics, we intend to kind of focus on helping learn a very systematic way of understanding and developing your technical specifications, its operational model, understanding what elements will then be required in your entire fleet for EV charging, everything put together, and then using those learnings to calculate the TCO. Yeah, so then you have completed your technical specifications part, then came out with the right TCO, and then you loop this back again because you may find that, hey, this vehicle is not meeting my requirements. Yeah, maybe the battery size of this vehicle is too high, your energy signatures are low. Even if you account for battery degradation, this is too high, and you may want to consider it optimizing again for a different vehicle segment. Some cases you may see that the kind of volumetric capacity is required by the vehicle is not there, though the payload capacity is there, but for the client for which you want to run these vehicles, they have those bigger boxes and lighter weights. Yeah, so those kind of requirements, then you can really kind of learn through with a very more control, like what do you want, why you want, and what it will give you in terms of returns. Then you go and get the right supplies from the industry. So that is the space where someone new who is looking to add to his fleet is would go through this approach. This approach is also very powerful when you are into the diagnostic phase. I know many of the operators, good friends, who are running three-wheelers, two-wheelers, EV fleet, and in this initial phase of growth, they have deployed multiple OEMs, multiple makes, and pretty much in the pilot mode. They are really learning across the different models, how they are performing, what are different issues. So this learning again can be used to help them to diagnose their existing fleets, diagnose their existing EV fleets, yeah, and figure out like where do they need to make the change, right, in terms of improving from the existing fleet performance, plus also like thinking of their next procurement which they will bring for a scale of phase, what are the right ways of handling it. So wherever you are in terms of your EV charging fleet ambitions and objectives, this is a very powerful way. And if you belong to an OEM community from the product development side, this allows you to dive deeper of understanding the client need, because as I said, like for the OEMs, Vikrant kind of shared that the commercial fleet has fairly fastest growth in the EV segment, but the product has not catch up that much in terms of its reliability, in terms of its performance, even in terms of its suitability, yeah, for the freight applications. So I think there is a lot that the OEM need to do at a much accelerated pace than the other passenger EV products. So this framework again can help you to allow understand the customer needs, yeah, and then convert them into your technical requirements for the products, yeah, and then be able to learn how very systematically you are able to develop this energy signatures, and based upon energy signatures, how are you able to right size your motor, your battery characteristics, specifications, chemistry, locations, even a decision between swap and fixed batteries, and what kind of charging infrastructure, time of charging, day and peak of charging, and how it will influence your battery and the combined TCO perspective for your customers, so that you are able to really build it. So back to you, Vikrant.
Yeah. Thanks, Rahul, for that elaboration. So, uh, as we spoke about, some of the steps would be the route energy estimation. So you'd be provided with a Excel-based tool where you can actually put in the cycles. So you'll be also provided with a few cycles, and you are encouraged to actually bring in some of the cycles which you also can collect. So this kind of data is usually available from the fleet tracking systems, or you can also go and collect this very easily with an app and a mobile phone, because all you require is the GPS location, the GPS speed, and the loading can also be logged in manually. So with as little investment as a few hundred rupees or few thousand rupees, you can actually also collect some of these duty cycles and bring them on into this tool, and try to estimate under different conditions what are what is the energy consumption, And typically, one of the thing that is of interest is this number. What is the energy consumption per kilometer for this kind of a use case? And if you actually take again, going back to the specification or the claimed range, if you calculate for this is for a typical three-wheeler operation, but the specification might give you this energy consumption figure much lower than in reality. So it could be, instead of the 70 watt hour per kilometer that it is showing here, it could be 50 or 60. That's what we have seen. A lot of manufacturers claiming as the energy consumption per kilometer. So here it is possible to actually look at your particular application and look at what would realistically be the energy consumption per kilometer. This won't be very off from the reality as compared to what are the claimed range, which is on a specific cycle under mostly standard conditions. Yeah, and even if there is given some plus or minus or some real life range, even those in our experience have been quite off from what you can estimate and what would be the reality. So this is extremely important because this kind of shapes the specifications or requirements for a particular application. And matching it with a generic information is where a lot of people have heartburns. Uh, there are a lot of stories about how the range expectation was 100 kilometers, and in reality, even with new batteries, we are only getting 70, 80 kilometers. Once you have an estimate of what is the energy consumption, we can quickly go to, for a particular battery size, what would be the state of charge profile across a particular schedule. So you could have a couple of trips in that schedule, and the charging also accounted for, and you can actually see if a particular battery is sufficient. In this case, it does seem to be sufficient because the minimum state of charge goes only to 70% from a starting state of charge of 97. However, if in any case it is something that you have identified as a issue, this falls really low. Then there are other solutions to this. One of those could be opportunity charging, where in the layover between two trips, while the delivery items are being sorted or they are being loaded, you could do a quick opportunity charging. By quick, I don't mean fast charging. By quick, what I mean is whatever time is available, in that however much charge you can push it in, you can. So in this case, you can see around 11% of charge can be pushed in, and instead of starting the second trip at 83, you can actually start at 94, and the eventual full charging that is required later, that overhead reduces. Typically this full charging, in this case, because it is only charging from say 70 or 80% to full, it shows only 1 hour, a little over 1 hour. But you can imagine if it has to charge from a very low state of charge, it will take 3, 4, 5 hours. And typically in the LCV segment, including the two-wheelers, three-wheelers, and the mini trucks and vans, you will very rarely see fast charging ability. Even if it is there, it is usually not recommended, because fast charging can potentially reduce the battery life, and you will have to replace the battery more earlier than you would doing the slow charging. So this opportunity charging can help you reduce that overhead of full charging, which either you can do overnight, or if it is possible for you to do those chargings in the windows where the vehicle is idle, rather than overnight. So that's also is possible. So There are many models around the charging, overnight charging and parking as well. We will look at those in our detailed sessions on these topics. Also, one of the important consideration which has been shown on the right is the charging time is again often approximated to whatever is the kilowatt hour energy capacity of the battery and whatever is the kilowatt rating of the charger. However, there is a portion of the charging, or for some duration of the total charging time, the current is actually much lower than the full current that the charger can provide, and that is a constraint imposed typically by the battery capacity to take in the charge. And because of that, you would actually get slightly higher charging times, slightly to significantly higher charging times than a simple division of how much kilowatt hour by how much kilowatt.
Vikrant, on the previous slide, just want to add, like, during the course, we will also look into different business models that typically goes in freight fleet operations, where the operator may be owning the asset and giving it out to either external drivers or full internal employee team. And there can be driver come owner of the asset models, especially more typical so in two-wheelers and three-wheelers for the kind of their penetration they have seen. And the charging characteristics would differ for this driver come owner segments, where they will also be taking the vehicles back with them overnight, and typically will depend on home charging, or if the EV fleet operator has to provide the parking and making provisions, safety and other things. So all these are also technical considerations depending on how your business model overall is. That will also determine your right charging selections between different options. So that the point of ownership of the assets and those business models, how it will also change the charging characteristics from different types of vehicles, that becomes very important. Where you charge these vehicles is another very important consideration, right? Because that will determine what kind of charging you can use. So all those considerations we will be exploring as well into the course. Over to you, Vikrant.
Yeah, thanks. So moving on to one more illustration of how understanding one vehicle schedule and incorporating charging requirements in it, then you can actually go ahead and do a fleet model. You can incorporate multiple routes, or you can incorporate for that route if you are running multiple delivery runs, how they would pan up and how many chargers they can share. You need not have a dedicated charger for each vehicle in your fleet. You can optimize the number of chargers that you would actually need using some of these techniques. And also you can look for opportunities to have redundancies in the system as well. So it's not just about having the right number of charges, but also making sure that even if so in this case, for example, it says number of chargers required is 1 for this hypothetical fleet. And if I add maybe a couple more vehicles, it will go to 2. However, we know because it's an integer, it's gone to 2. But the second charger is probably only going to charge a couple of vehicles. However, it can be a good redundancy in the system in the overall fleet management. So this could be one of the use cases. There could be multiple use cases for different vehicles in the fleet. And overall, at the fleet level, if you can have a bird's eye view of how much is the utilization of your chargers, and then you can build in proper redundancies as well, so as not to actually have too many chargers and at the same time not to be dependent on all chargers being operational all the time. You have maximum utilization, but one charger fails and you are missing your SLAs. So with that, some of the illustrations, let me go through the program schedule itself. This, in a sense, is a 5.5 week long course in terms of delivery, but we would engage you a couple of weeks more through some of the assignments and the project itself. The classes on weekdays, that will be Monday, Wednesday, and Friday. They will be in the evening, 7 p.m. to 8 p.m. India time, so as to ensure that you can still attain these while managing your day job and your other commitments. And then on Saturdays, we will have some hands-on work on in terms of calculations and using these Excel tools, and those we will do between 2 and 4 p.m. India time. So the major modules that we will cover is starting with basics of electric vehicle fleets, going into the modeling of those fleets. And once we know the modeling techniques, and we do one very base case, from there on, we can actually add complexities to our studies, looking at the EV fleet disruptions in module 3. Then going on into module 4 with a robust plan, how much is my actual cost of ownership, how to account for capital and operational expenses, and then going into module 5, where all this plan in reality how can be implemented based on what is available in the market, what kind of financing is available, what kind of models are available, what kind of options are available in terms of upgradation of the technology or retrofitment from IC engine to electric vehicle, how mixed fleet work. Some lot of fleets currently are mixed fleet, meaning some of the vehicles are IC engine vehicles and some are electric vehicles. So how do they work in tandem with each other, and so on. And eventually we will get down to modeling one of these disruptions in our project, um, uh, to actually go through and apply all the modeling techniques as well as all the considerations that we have seen into a real life like scenario. So this is a very engaging course. There will be, in addition to the sessions that I had listed in the previous slide, there will be additional engagement for you in terms of assignments. Again, doing some base case studies, and then also doing some sensitivity studies. And then they are all forming a portion of the qualification criteria for the certification. Let me be very clear upfront. The certification is not just for participation. It is actually a certification that you have acquired these skills, and for that it is necessary to do evaluations, including a multiple choice quiz, a mini project, the assignment evaluation, as well as since this is a live program and it is quite interactive in our experience. So we have run multiple batches of similar courses since last year. It is the interactive setup of these sessions also help enhance the learning, which you would miss on if you are doing it self-paced or just watching videos. So attendance also has a certain weightage to just maximize your learning opportunities. I spoke about the mini project. Here um, you would be modeling one of the disruptions in terms of the energy consumption, the route selection, charge scheduling, and total cost of ownership. from the base case study, whatever is the disruption causing you to have deviations in your schedules and plans, and the impact of that, the risk of that, and to manage the risk, how much money has to be reserved. So all of these things you will be able to do on one or two disruptions. This will be a group activity. We will form teams as we go through the program, and we will also scope these projects to be reasonably achievable within the 6 to 7 weeks. With that, I will come to the trainer. So Rahul and I and Soma, all three of us are here. So we will be taking you through each sessions together through the theory sessions as well as the practical sessions, the tool usage tutorials, and so on. All of us have a diverse background in automotive industry, and we have seen the product development cycles, we have seen the deployment, we have seen the field issues of automobiles in overall, and electric vehicles in particular. So we also would get from for particular sessions or particular subject matter, we would also have some experts in terms of guests. So those sessions would be announced in advance, and we will involve some of the experts also in taking you through their experiences while applying some of these principles, as well as where things can go wrong, what to watch out for. I briefly mentioned our primary calculation tool is in Excel, and we would encourage you to have at least some spreadsheet tool, not necessarily Excel. If Excel is not accessible, you can have any other spreadsheet tool like LibreOffice or OpenOffice or even Google Sheets to do some of these calculations with us, and then be able to use the tool that we have provided. We will work through a learning management system. Today's session is a demo session. We have used the webinar platform. However, once you get registered and enrolled, you will get your own LMS login IDs, and using those, you will be able to see what is the schedule. The session links would be provided there. The videos would be provided also for reference. If you miss something, or if you want to go back and listen through some of the sections of the sessions, so those videos will be provided. There will be notes, handout notes also available there. And then all your assignments, submissions would be through this LMS. So with that, I think I took more time than I promised, but let me throw it open for Q&A, and leaving this slide for reference about the course. So you can unmute yourself and ask questions, or you can also put them in the chat box.
There is a question like what vehicle segments this course will be covering, and what it may or it will not cover.
Yeah. So this course is focusing on light commercial vehicles. So as the graphic shows, we will be covering or focusing on two-wheelers, three-wheelers, and light trucks. We won't be going into when you saw the graphic about the e-commerce applications, there was also this long haul, which partly is taken up by these intercity trucks. So those will not be part of this. But other than that, pretty much everything, the first mile, the last mile, the mid mile, covering the two-wheelers, the three-wheelers, and the light commercial vehicles will be part of this program.
Sure. Just to add upon to what you added, Vikrant, like there is another course that is under development that will actually focus on medium to heavy duty trucks in the long haul intercity freight transport, what Vikrant is suggesting. And there we actually want to cover both technologies. So we will take systems engineering perspective, which Vikrant walked through us in this presentation, but we will bringing both technology aspects, including hydrogen. So that course will allow you to understand the electrification options using pure battery versus hydrogen, and on some right metrics comparing both of them. So fold upon that will be coming. But for this course, with the current developments and the focus of EV operators in EV OEMs, we will be focusing on this two-wheelers, three-wheelers, and L5 category like mini trucks for this purpose. So there is one question, Vikrant, like if I want to design my own e-vehicle for L5 or L7 vehicles, will those models be made in this course from scratch?
Yes, you will be provided with the ability to make these models also from scratch. So energy models and scheduling tools. However, we will also provide you with the tool that we have built, because in the models, along with these calculations or the physics equations, there are certain assumptions that have to be made, because all the data is not available. It's otherwise it becomes a chicken and egg story that I want all the specifications of the vehicle to come up with the specifications of my vehicle. So there will be certain assumptions with which we would work, and those assumptions we will help you make, and you are encouraged to even take this tool that we would provide, or if you are enthusiastic about it, you can build this tool from scratch, and we will support you in that activity as well. So since this is a reasonably longer duration course as compared to our other courses, you will have that time, and we will spend time with you in explaining to you how these certain calculations are done. And then it would be actually more beneficial to you if you can replicate those calculations, build your own tools with our support, and then later you gain the confidence of using those tools and applying it to your real life problems.
Then there is another question I'm reading, like there is no current equivalent of Tata Ace kind of a EV product in commercial segment as of now in India. Will this course help me to kind of think through, and what are the potentials of electric three-wheelers, which is a new segment for existing freight usage? What potential it has to take some of the first and last mile trips from the conventional IC, Tata Ace, and big van kind of a products.
Yeah, sure. So there are two answers to it. One is, of course, although we do not have it now, there are vehicles in the pipeline. Primarily, it doesn't matter to the user whether it is a three-wheeler or a four-wheeler, as long as it is stable and it can do the job. It can carry the certain amount of volume that it is supposed to carry. And there is a sweet spot of those volumes based on the application, where the Tata is currently placed, the IC engine variant of it anyway. And there is obviously a demand for that kind of application. Now, as I said, it doesn't matter whether Tata Ace in its electric form is a three-wheeler or a four-wheeler, uh, but as long as it is able to do the job that the current Tata Ace IC engine is able to do, it would be good. And we will also learn how to understand the requirements in terms of technical specifications, because um, uh, OEMs have to cater to a wide variety of applications. And if we only talk about I need so much range, OEM will say, yeah, this is the range you will get. But then you go and use the vehicle for that particular application, you don't get it. That is because you have not spoken their language, if I may say so, that I need the range in this kind of duty cycle, in this kind of operating conditions, with this kind of driver behavior, in this kind of traffic, in this kind of loading conditions. Then they would actually be in a position to help you, because otherwise who is better to discover your application than you? And we are going to help you do that using these systematic and standard techniques, so that you can capture the essence of your application in a particular format, and then the OEMs will be in a much better position to help you. As I said, there are two answers to it. Yes, there are vehicles in Tata Ace segment which are in the pipeline. There are options of retrofitment being explored also by some fleet owners. And then there is a possibility of these three-wheelers in L5 category, particularly taking on the role in some of the applications, if not all, of Tata Ace kind of.
There is a question, will the course also look into the aspect of route optimization? Does it come under route selection? So yes, the answer is yes. Once we have done the energy signatures, we then work upon the route selections and optimization. So for doing that, you need to develop the energy signatures for that vehicle use on each of those routes, and that helps you to select the route selection part. And then looking into the overall fleet system at your boundaries, then you kind of look upon optimization for the fleet performance in terms of optimizing the number of chargers to share charger techniques and multiple things. So that's where you kind of then go with the optimization.
Yeah.
One question says, what's more of a better option, retrofitting an existing vehicle or buying a new one from owner's point of view? So I think both of this thing remains as an option. Again, it depends on your use case, on the total cost of ownership, especially when you're talking of retrofitting. Yes, it will save on the capex part, and there are good companies who have started providing the retrofit solution. And I think for Indian context and even for other developing contexts, we are working currently in Zimbabwe with 98% imports of vehicles, and these vehicles are almost 98% time again they are pre-owned vehicles, of average life being 10 years. So we definitely see that there's a huge retrofitting potential, and I think in India there are companies who have already started working on retrofitting. And in freight segments, because it's not about the comfort of the vehicle, but it's really about the what volume you can kind of service with those vehicles. I think they are good candidates for retrofitting. How much they will perform, even for some lack of or drop of efficiency versus a new vehicle purchase, versus at what cost it is coming, those things will determine the respective use cases. So I think as a business owner, or even as a startup looking into these options, you have to really explore. This course will actually allow you to learn the nuances, equip you with skills and tools where you are able to take these decisions very qualified, both on the techno commercial point of view together.
Yeah. So as Rahul was saying, we and I have just marked it out. We do have a dedicated session on this, and we would also support if someone wants to take that up as a project to do this analysis of what will suit for a particular application. We usually discourage generic answers, because they have broken many hearts. Let's leave it at that. So let's not get into generic answers. Let's work on the specifics that you are struggling with, and let's try to solve those.
So while I think you shared a slide on projects, I think let's relook into the project definition, because you are very right that we would actually want the projects to really resonate with what you are intending to do or you are already doing in your organization or in your capacity. So if you are a team from an OEM who is working on a product, let's say on a Tata Ace retrofit or a Tata Ace equivalent electric product, we would encourage you to take that project and apply all the learnings of the tool and dive deeper into those product aspects with this learning. If you are looking to a retrofit options and that is interesting, we will find a right team between you with right skill sets to work on a project basis. In fact, that was the reason to allow you to give more time in this session, that we changed the structure of the program. So from 1.5 hours, we have made it 1 hour, so that the duration of the program gets longer and the teams get more time to work with each other on the projects. We will have industry experts, especially in retrofitting. One of our faculties and experts and good friend, they have done quite strong work on retrofitting Tata is kind of a vehicle. So we will have it, what Vikrant is pointing here, we will actually have a dedicated session on retrofitting and no superficial theories, but real the people who have done it, and then also connecting it to the TCO analysis so that you are able to evaluate those options and study them for the different applications you will be looking at. I also want to add, now that we are coming very close to the end of time, uh, for two stakeholders. One, a EV fleet operator who is running a EV fleet already, be it any vehicle segment, right? And second, for the EV OEMs who are producing the products or have a pipeline to develop a product in the freight category. Just as a token of appreciation for the work they are doing, we have a very special scheme, which is basically 2 for 1. So basically, at a cost of one professional participant, we will allow two participants to join at that same fee. This is one of our way to kind of giving back and ensuring that the learning of this program gets strongly embedded in your organizations and help you drive performance and improvements. So if any of you would be interested in availing that, I request that you drop us an email, and we will do your registrations accordingly. There is an, and as part of this program, for those EV operators who are supporting this program in this format, 2 for 1 program, we would also be keen to kind of make you as an industry partner to this program. As I said, like, learning is mutual. We would want to use and work on these projects for some of the case studies and learnings developed for this program. If someone senior in your organization is willing to come as a guest expert on this program, and with the learnings that you have developed in the program, and with more few things getting added, we would encourage those kind of case studies also into the program. So if any of you would have interest to partner with us, and you see this program as really benefiting your organization or your knowledge contributing widely to the global industry in freights electrification, do reach us out, and we will really figure out ways of working and collaborating with you on this first very global unique programs.
Yeah.
Vikrant, any last thing to add?
There is one quick question on does the load carrying capacity change when we convert vehicle from ICE to EV? Yes, it does change because you have to account for the battery mass. So retrofitting, there are pros and cons. We will discuss, as Rahul said, in detail, and we will have people who have actually worked on the retrofitment of IC engine vehicles to electric vehicles, and maybe even and they have also worked on upgrading from, say, lead acid battery to a lithium ion battery architecture. So we will discuss those in detail, and uh, these are some things we don't want to give generic answers to, as I said. One quick thing I would like to add is uh, this is a very good opportunity also to not only learn but apply these skills immediately. As Rahul said, you can bring in project ideas, which are welcome. Even in our other courses, we do welcome your project ideas, and we can help you scope what is required in this particular certification, and you can continue working on this other aspects, or continue the work beyond what are the requirements of the certification on that project beyond. So these are some opportunities which should not only have the learning stick, because this is essentially experience based learning, but also you can apply and get the results of those immediately. It's not like something you will. So oftentimes education or trainings are thought of as investments, but these investments you can actually start getting returns very fast. In fact, almost immediately.
And I think there's one question just to clarify that 2-for-1 scheme would not mean that you will be given 50% discount if just one person participate. So encourage you to think in that manner, that two people from the organization are coming and we will charge them as a fee for one. That will also kind of keep a good buddy for you from the organization. So when you dive deeper into the project, you can select something very specific and relevant to what the work you are doing and taking it forward, even within your organization. So that is the whole idea of extending that scheme for EV operators, EV fleet operators, and EV OEMs. So great, friends. Thank you very much. I do make a call of driving and doing your registrations quickly, and reach out to your friends and network whom you think would also be interested and benefited from this course. So have a great evening, and we look forward to see you on the course. Thank you very much. Thank you very much, Vikrant, for lovely sharing of the course structure and how will we make it very useful to the industry. Thank you.
Yeah, thank you all. Take care. Stay safe.
Thank you all. Have a good day.